Hello students, welcome to this video session of Isro solutions for mechanical engineering exam that was conducted today. In fact, this is one of the prestigious examination. Usually the mechanical engineers will be waiting to write because this is an exam conducted in the all India level. So today I am going to give the solutions for this. My name is Sekhar. This is from M Sigma Gokulam. I am one of the senior most teachers in mechanical engineering across India, having worked for many years at Delhi, Hyderabad, etc. So I am going to discuss about all the solutions and the keys of the Set D paper of the mechanical engineering paper that was conducted in the today morning. Paper strength, if you see the depth of the paper, if you see the paper toughness, if you see, it is moderately tough, not very tough, it is moderately above average, I can say. Some questions are quite easier, but some questions I made it a bit lengthier as such, and some questions do not carry any answers and there is an ambiguity also. I will discuss each and every question of all the 95 questions, out of which 80 are technical and 15 are aptitude. For everything I will give the key and I will discuss about the solutions also. For some topics I may not give the complete solution, but I will give the key, but some other topics I will give the complete detailed solutions also. So the very first question goes like this. This is the question on the operation research. A manufacturer has the following data regarding a product: fixed cost, variable cost, selling price, production capacity per month. If the production is carried out at 75% of the rated capacity, then the monthly profit is. The solution of this could be given like this. Production capacity is 1600, monthly production is 0.75 into 1600, that is 1200. Fixed cost is 80,000 rupees, variable cost is rupees 350, selling price is 500 rupees. Then the equation for calculating the profit will be fixed cost plus variable cost into 1200 plus profit is equal to selling price into 1200. From this, the profit will be 1 lakh. Answer is A. So answer is A for this very first question. Question is on the operation research and as well as the industrial engineering. The second question goes like this. For a PET activity, the optimistic time is 6 minutes, the most likely time is 9 minutes, and the pessimistic time is 16 minutes. The expected time of the activity in seconds is. So the given data is optimistic time is 6 minutes, most likely time is 9 minutes, pessimistic time is 16 minutes. Therefore, the expected time, the formula is given by TO plus 4TM plus TP divided by 6. This is 58 by 6 minutes. That will be 58 by 6 into 60 seconds. That will be 580 seconds. Answer is D. Now this is the question on the strength of materials. A beam, a cantilever beam which is propped at its end. A beam is subjected to the uniform load, uniformly distributed load, WC per unit length, and MA, VA, VB are the reactions as shown in the figure. The expression for the shear force Vx and bending moment Mx is given by. See that, look at this X variation is given like this, right? This is the AB is the beam, this is the bending moment, moment acting at A, this is the reaction at A, VB is the reaction at B. WC is the uniformly distributed load acting all along the length of the beam. He is asking you to write the equation for calculating the shear force in terms of X, x is always measured in this direction. Look at this x direction. And also to write the equation for the bending moment in terms of x as the x is measured from left to right. If you just take any section at a distance of x from the left end, if you just consider a section xx, now I would like to write the equation for the shear force. What is the general convention for calculating the shear force? Consider one side of this section, consider the beam existing on one side of this section, treat all the upward forces, treat if left hand side upward forces as positive and left hand side downward forces as negative. If you just take the right hand side of the beam, right hand side downward forces as positive and right hand side upward forces as negative. And because x is measured from left to right, I have taken the left hand side of the section considered, left hand side of the beam. So what is the upward force here? Upward reaction VA. So VA is upwards. For the equation, for the look at that equation there, VA is upwards there. So this is the VA is the plus VA, and there is a for a distance of x, if WC is the load per unit distance, what is the total load acting? WC into x, which will be acting downwards, therefore it will be negative. Please remember the convention that if you just consider the left hand side of the beam, all the upward forces as negative and downward forces, upward forces as the positive and downward forces as the negative. If you just take the right hand side, downward forces as positive and upward forces as negative. But why I have considered the left hand side is x is measured from left to right. Look at this here, look at this figure, he has given the question paper itself. So we are measuring the x in this direction. So I have considered the left hand side of the beam existing on the section considered. VA is acting upwards. This is a plus VA minus WC into x, because this load WC is per unit distance. For a distance of x, what is the load acting? WC into x. Look at this, there is a sign minus. Okay. So that is the shear force. That's all. There are only two forces. One is reaction, another is UDL. For the equation for the bending moment, if you just look at that, bending moment at this x, xx, bending moment will be, so this there is a bending. What are all the forces acting here? One is VA. VA is having a moment corresponding to x. VA into x, that is a clockwise moment. Like in a clockwise moment, it is a positive. MA is positive. MA is positive. VAX is positive. And whereas for this uniformly distributed load, what is that procedure? UDL, you have to shrink it to a point load here, acting at a distance of x by 2. So what is that load there? Total load acting at the midspan of this midspan of the beam considered, W into x, acting exactly at the midspan. W into x, look at this, WC into x is acting at a distance of x by 2 from the from the section considered. So WC into x by 2, WC x square by 2. But this is the one is hogging moment, other is sagging moment there. So this is minus WC x square by 2. This is anti-clockwise. Look at this. This is an anti-clockwise moment. This is clockwise moment positive. VA into x, that is also positive. Whereas the WC into x by 2, that will be acting in this direction. Therefore, that is why it has got a minus sign here. So answer is D. Once again I am telling, to calculate the bending moment at any section, take the hogging moments as negative and sagging moments as positive there. Okay. So for this, based on that particular convention, WC into x is the load acting here at a distance of x by 2. Therefore, its moment will be anti-clockwise direction. That is why it is a negative. Whereas VA into x, that will be clockwise positive. And again, this bending moment is already there. This moment acting, like the MA is acting at the moment is acting at A. That will be again clockwise. That is also positive there. So answer will be D. This is the direction of the moment for the WCX. Answer is D. Look at the fourth question. A cantilever beam of cross section A, moment of inertia I and length L is having a natural frequency W1. If the beam is accidentally broken into two halves, the natural frequency of the remaining cantilever beam W2 will be such that it is W2 will be greater than W1. The fifth question given like this. Vapor pressure in mm of mercury of solid and liquid ammonia is given by LNP 23.1 minus 37.49 by T and LNB minus 19.6 into 3049 by T. The T should be have to be taken in Kelvin. Find out the triple point. What is this triple point? Based on the pure substances concept of thermodynamics, triple point is the point where all the three phases of any pure substance can coexist in thermodynamic equilibrium. For example, the triple point of water is 0 degrees Celsius, where the solid ice, liquid water and water vapor, all of them will coexist in thermodynamic equilibrium. So, there is a that means at a triple point there is a chance for the phase transition either from solid to the vapor or liquid to the vapor also, because all the three phases are coexisting in thermodynamic equilibrium at a triple point. So, I just like to write here, triple point is the point where the phase transition between all three phases. Look at this, between the phase, that means a solid could become into a liquid or it would become a vapor, or a liquid could become into a vapor and as well as into the solid. So, all the three phases could coexist in, all the three phase transformations, phase transitions could happen at that point called triple point. Between all three phases occur. For that to happen, the phase transition curve between solid to vapor and liquid to vapor must coincide. In fact, that phase transition from the solid to vapor also we call it as the sublimation. That process of solid directly becoming into the vapor is also called as the sublimation. So, triple point is the point where all the three phases of a pure substance, solid, liquid and vapor could coexist in thermodynamic equilibrium. But the triple point value for the water is 0 degrees Celsius. For that matter, that is the reference point for measuring the enthalpy and entropy of the steam. All the steam properties are taken with reference point at the triple point of water for information. So, triple point of water is 0 degrees Celsius, but here it is asked for the ammonia there. Look at this. Liquid ammonia there. So, he has given the vapor pressure in mm of mercury for solid and liquid ammonia is given. So, we could equate this. Look at this. This is for the solid, this is for the vapor. Therefore, both are happening at the same temperature. So, I could equating this LNP is equal to 23.1 minus 3749 by T is equal to 19.6 minus 3049 by T. You will get the value for the T as 200 Kelvin. This is the answer. Triple point of water, triple point of the ammonia based on the given data. We could even show it also like this. On the phases, this is a solid phase, liquid phase. All three coexist here. If it is a question on the welding, a weld with a triangular cross section is shown below to be produced on a steel workpiece by a shielded metal arc welding operation using a steel electrode. If a 24 volt power supply is used and the welding speed is 12 mm per second, what is the current needed? Assume efficiency as 80% and the specific energy to melt the steel as 8 joule per mm cube. The answer is 125 amperes. A slider moving outward on a rod OR with a velocity of 3 meters per second and acceleration of 9 meters per second square. The rod has an angular velocity of 7 radians per second counterclockwise. Look at this, counterclockwise. about O and an acceleration, angular acceleration of 12 radians per second square clockwise. This is an angular velocity. This is an angular velocity. This is angular acceleration. The magnitude of the absolute acceleration of the slider at location A in meters per second square will be, answer is 50. 50. B is the answer. If the load acting on the ball bearing is increased 2 times, its life will reduce by 8 times. See, some questions are straight questions they have asked, and some questions were a bit complicated also. As you keep doing the problems paper, you will come to see that some questions are very straight. Just by reading the problem like this, you can keep. But some questions need calculation and logic application, etc. Paper was moderately tough. I can say that it is not as easier as the earlier papers. It is not as easier. Definitely, I can say that if you just observe for the last 6 or 7 year paper, 7 times ISRO papers, this paper is not as easy as them. But there is some mismatch of the subjects also. In the earlier papers, you must be seeing so many number of questions may be asked in the refrigeration and air conditioning, etc. But here, the few questions were asked from the subject. But the distribution of the questions across various subjects of mechanical engineering, they are not that uniform as compared to the previous papers. The paper is moderate standard, I can compare. Next question will be, an old clutch is to transmit a torque of 100 Newton meter. The inner and outer diameter of the clutch plate is 100 mm and 200 mm respectively. The force required for the engagement is, assuming that coefficient of friction mu as 1/3 with a uniform wear theory. Answer will be A, that is 4 kilonewtons. It is a problem oriented with the friction because any clutch, of course, that is operates based on the friction principles only. Answer will be 4 kilonewtons. The specific stiffness of a material is defined as the specific stiffness will be defined as Young's modulus divided by density. Answer is C. The type of gear used to transmit rotary motion between non-parallel and non-intersecting shaft will be worm gear. The type of gear used to transmit rotary motion between the non-parallel and non-intersecting shaft is worm gear. Which of the bearings given below is not suitable for the axial thrust load? It is a straight cylindrical roller bearing that is not suitable for the axial thrust load. Look at this. What is the change in entropy when water is vaporized? At 100 degrees Celsius, latent heat of vaporization of water may be taken as 20 to 38. When water is changing its phase, at 100 degrees Celsius, which is called saturation temperature, its temperature will not change from the saturated liquid to dry saturated vapor. This state is dry saturated vapor. Its temperature will not change. That saturation temperature is 100 degrees Celsius. The corresponding saturation pressure will be 101.3 kilopascal. Okay. Now, what is the change of entropy? We know that ds is equal to delta Q R by T. But this temperature is not changing. So, if you just look at this is a saturated liquid state, which is called as change in entropy during phase change. Change of entropy during phase change. Just phase change is happening. During phase change will be, what is the heat we are supplying? Temperature is constant. Because during phase change, temperature is constant, we can take it outside 1 by saturation temperature. Because when you integrate both sides, integral delta Q R by T, that will be the Q supplied. What is the Q supplied, which is called for the phase change? What is the heat supplied for the phase change between liquid to vapor? It is called as this heat is only called as the latent heat of vaporization. or which is also called as the enthalpy of vaporization. Latent heat of vaporization, which is the same as known as the enthalpy of vaporization, which is also called as the Hg minus Hf. Therefore, Sg minus Sf is equal to that latent heat only is indicated by Hfg. Tsat, that is Hg minus Hf also we can call. So Hg minus Hf or latent heat all mean the same. The Hfg or Hg minus Hf or the latent heat all mean the same. Latent heat by Tsat. He has given the latent heat. How much is the latent heat given? 20 to 38. 20 to 38. The temperature we have to keep it in Kelvin always. This answer will be 6 kilojoule per kg Kelvin. This is the SFG value. This is the SFG value or Sg minus Sf. This Sg minus Sf only is called as SFG. The change of entropy for the water during that phase change happening at 100 degrees Celsius or at 101.3 kilopascal saturation pressure. Incidentally, as the saturation pressure increases, saturation temperature also will increase. Incidentally, the same latent heat of vaporization at critical point becomes 0. This latent heat is 0 at the critical point. This is a question on thermodynamics. Examine the following statements. Work is high grade energy. Very much correct. Heat is low grade energy. Work is high grade energy. It is possible for a heat engine to produce work in a cycle by exchanging heat with bodies at the same temperature. Definitely wrong. To produce work from a heat engine, that heat engine must operate between two reservoirs which are at different temperatures. We can expect to operate the heat engine to produce the work only when it is operating between two different reservoirs at two different temperatures. Because heat engine is receiving the heat from the high temperature reservoir and converts a part of that heat into the work, and remaining heat it will be rejecting to the low temperature reservoir. So we cannot think of operating a heat engine exchanging heat with only one reservoir which is at a single temperature. So heat engine must operate between two reservoirs at two different temperatures. But this is wrong statement. It is impossible to construct a device while operating in a cycle will produce no effect other than the transfer of heat from low temperature cooler to a hotter body. This statement is only famously known as Clausius statement of second law. Clausius statement of second law of thermodynamics. So this is correct. Correct statement. So 1 is correct, 3 is correct. State 1 and 3 are correct. 2 is wrong. The configuration of a planar mechanism, planar 4-bar mechanism with frictionless joints is shown here. The suffixes 1, 2, 3, 4 represents the fixed input coupler and output link mechanisms. This is 1, this is 2, this is 3 and this is 4. Okay. If Ti and To are the torque to the input and output link, then what is the mechanical advantage To minus Ti of this mechanism? Mechanical advantage Ma is equal to To by Ti is equal to omega I divided by omega O. That will be equal to infinity. Answer is C. The elastic strain energy stored in a rectangular cantilever beam due to a bending moment M applied at the end is given by. There is a cantilever beam, a bending moment is applied. What is the elastic strain energy? Strain energy stored in an elastic member, it is given a half into stress into strain into volume. That strain energy stored per unit volume only is called as a resilience. Okay. And the strain energy stored up to the elastic point is called as the proof resilience, which is nothing but the area of the stress strain diagram up to the elastic limit. So the strain energy, the maximum strain energy stored inside the member up to the elastic limit per unit volume is called as the proof resilience, which is also called as the modulus of resilience. So this answer will be, but stress by strain is equal to Young's modulus. Therefore, epsilon is equal to sigma by E. If you substitute this there, you will get the strain energy will be sigma square into volume by 2E. Answer is B. If you just substitute here there, the solid bar 50 mm in diameter and 2000 mm long consists of a steel and aluminum part joined together. This is the steel part. This is the aluminum part, right? Diameter is 50 mm. When a force, axial load force is applied to the system, obviously there are tensile stresses exerted in the steel and in the aluminum part. They may be having a different length also. They may be having a different lengths. But what is common between both of them, because area of cross section is same, load is acting along the tensile load is same, stress is given by load by area of cross section. Stress in steel is equal to stress in aluminum, right? Because load is same, area of cross section is same, diameters are same, okay. But stress by strain is equal to Young's modulus, okay. Therefore, epsilon into E, epsilon is the strain, this is the strain, sigma is the stress. So, sigma epsilon will be sigma into E, that is sigma into E of the steel, sigma will be epsilon into capital E, Young's modulus. Therefore, epsilon into Young's modulus of the steel is equal to epsilon into Young's modulus of the aluminum. He has given the strain in the steel, look at this. He has given the strain in the steel, he has given the Young's modulus of steel, he has given the Young's modulus of the aluminum, okay. Then you can easily get the strain in the aluminum. He has given these, look at this. This is the strain in the aluminum, that is epsilon of the steel into what is the E of the steel? 200 gigapascal. What is the epsilon of the aluminum? It is 800 micrometer per meter, because strain will be very small. The change in length, what do you mean? How do you define by strain? Change in length by original length. What is the Young's modulus of the aluminum? 70 gigapascal. Now you can easily get the strain in the steel. That will be 280 micrometer per meter length. This is the strain in steel, okay. End to end, the rods are attached end to end. Two flanges are connected by a single bolt of nominal diameter 10 mm and is preloaded to a torque of 30 Newton meter. An external tensile load of 10,000 newtons is applied to the joint. The torque coefficient is 0.15 and joint stiffness constant is 0.2. The maximum tension in the bolt is. The problem could be done like this. D nominal diameter was given 10 mm, preload torque 30 Newton meter, external tensile load is given as 1000 Newton, torque coefficient it is 0.15, then preload torque will be D nominal into KT. Therefore, F preload will be that will be 20,000. Total load on bolt will be F preload, which is of tensile, plus F external, that is also tensile load. That will be, both will be added. If you add it up, it will be 30,000 newtons. Answer will be D, the maximum tension in the bolt. T meaning for tension. The Mollier diagram is also called as the enthalpy entropy chart, one of the most famous chart used in the steam problems, Mollier chart. These are all the constant pressure lines. This is the dry saturated vapor line. This is all the superheated region. This is the wet region. This chart is called as the Mollier chart, enthalpy entropy. All the problems of the steam nozzles, Rankine cycle analysis, most of the problems of the steam problems are done by using this chart called as the Mollier chart or Mollier diagram, which is an enthalpy versus entropy chart. See, some questions are quite easy like this. It is a very fundamental, very simplest question. But at the same time, if you just look at that, some questions are taking a lot of time. So, either it is very easy or it is something like a bit tougher. The question paper was like that. You are seeing all extremities. Real gas behavior approaches ideal gas when the pressure is very low and the temperature is very high. Ideal gas is the gas which obeys PV is equal to nRT at all pressures and temperatures. At all pressures and temperatures. That is ideal gas, which obeys all the gas laws at all pressures and temperatures is called as an ideal gas. But when you come to the real gas obeys a different equation that is called as a van der Waals equation, P plus A by V square into V minus B is equal to RT. This is the van der Waals equation of state defined for the real gas. Van der Waals equation of state. This is the equation of state defined for the ideal gas. Equation of state defined for the real gas. But real gas almost obeys like ideal gas at very low pressures. But as P tends to 0 and T tends to infinity at very high temperatures, real gas and ideal gas almost become same. Real gas behaves like a ideal gas. There are no intermolecular, ideal gas assumes that no intermolecular force of attraction or repulsion, molecules don't have the volume, they are the point masses, okay, collisions are perfectly elastic. That kind of a behavior we adopt for the ideal gas. Real gas almost behaves like ideal gas if the pressure is very low and temperature is very, very high. Answer is D. High vacuums and high temperatures, I can say. P tends to 0 means very high vacuums and T tends to infinity. Real gas and ideal gas will be the same. A stainless steel rod of diameter 12 mm is kept on frictionless surface. One rod is there, kept on a frictionless surface. It is heated. Temperature change 400 to the 300. It is heated. What is the thermal stress induced in the rod? Zero. Zero, because answer is zero. What is the reason? Since no expansion is prevented. The reason is no expansion of rod is prevented. No expansion is prevented. No thermal expansion. No thermal expansion is prevented. So there is no stress induced. If same question is if is asked like this, supposing if there is a rod like this fixed between two walls, now we are raising the temperature, some delta T is there. Definitely now there is a, supposing if the temperature is increased, definitely the rod will expand, but now the rod is not allowed to, rod is likely to expand, but these walls are preventing that expansion. Supposing if the temperature rise of the rod is there, this rod would like to expand, but the rods, these fixed walls prevent that expansion. Therefore, there will be a compressive stress. In case if the delta T is positive, if the same thing is happening between the two walls, there will be a compressive stress induced if there is a rise in temperature is there. But here, and moreover, he has given a frictionless thing. The rod is expanding very freely. The rod is expanding freely. Rod is, no thermal expansion is prevented. Therefore, there is no stress induced. A thermal stress will be induced inside an elastic member only if all the expansion or if some of the thermal expansion is prevented from happening. If some of the thermal expansion of the entire expansion is prevented from happening, then only there will be a thermal stress. That could happen whether a compression also. If there is a temperature is decreasing, the rod is tend to decrease in its length. If the, because any metallic bodies, they have the thermal expansion, they exhibit thermal expansion properties or thermal contraction properties because of the change in temperature. Okay, now there is stress. Now there is stress here in this situation, thermal stress, but not here because rod is freely expanding. In the question number 22, there are two different springs connected to the mass like this. Answer will be B. The natural frequency of that vibrating system will be, which is one of the most commonly asked question. Two identical springs having the same stiffness. A damped spring mass system is forced to oscillate at t is equal to 0 by the application of an impulse force. Which of the following is true? Answer is, if the damping ratio is between 0 to and 1, the system will eventually come to the rest. A damped spring mass system is forced to oscillate at t is equal to 0 by the application of an impulsive force. Sudden impulsive force is acting on a spring mass system. And what is the result there? If the damping ratio is between 0 and 1, the system will eventually come to the rest. What is the kind of deformation that occurs in shape memory alloys? It is thermoelastic. The equation of motion of a spring mass damper system is given by x double dot for 4x dot plus 16x is equal to 12 sine phi t. What is the damping factor? Answer is 0.5. Damping factor will be 0.5. It is a problem on vibrations. This is a problem on engineering mechanics. In an accident site, tire marks show that a car was traveling along a straight level street, skidded for a total distance of 23 meters. A car skidding, maybe because of suddenly brakes were applied, a car was skidding, it is coming with a velocity u, and after skidding it is traveling a distance of 23 meters after the brakes were applied, and finally the car halts. Final velocity is 0. The total distance travelled is 23 meters. Coefficient of friction between the tire and the road is estimated to be, mu is given as 0.5. What was the probable speed of the car when the brakes were applied? Car is moving, suddenly brakes were applied. After covering a distance of 23 meters, the finally car is coming to the halt due to the frictional force acting. There is only one force that is acting on the car is friction force. Okay, well, there is only one force acting along the travel of the car. Friction force is equal to mu into Rn, normal reaction. What is a normal reaction? Mg, mu into mg. There is only one force that is acting, right? Opposite to the direction of the motion. Mu into normal reaction is mg, weight of the car. That mu may be the coefficient of kinetic friction. It may not be coefficient of static friction, it may be the coefficient of kinetic friction. So, F is equal to ma and v square minus u square is equal to 2as. There is only one force that is acting, F is equal to ma. Acceleration will be F by m, mu mg by m gets cancelled, mu into g. Acceleration is mu g, that is v square is 0 square minus u square is equal to, because it is a retardation, more correctly it should be called as a, not acceleration, it is a retardation. Negative acceleration is also called as the retardation. Therefore, it becomes minus there, minus 2 into mu into g. What is the distance travelled there? 23 meters. Mu is given, g is 9.81, you may take, you will get the velocity in meters per second. But he has asked in kilometers per hour. How to convert into the meters per second into kilometers per hour? Okay, 18 by 5. Okay. So, you will get 54 kmph. That is the speed of the car when the brakes were applied. I just applied the Newton's second law of motion, F is equal to ma. There is only one force that is acting, F is the friction force is equal to mu into Rn. What is the normal reaction? Weight is acting downwards. Normal reaction will be acting upwards. Okay. Because there is no motion of the car along in this direction, normal reaction should be equal to the mg. And according to the law of friction, friction force is equal to mu into Rn, mu into mg. F is equal to ma, I got the acceleration or retardation more correctly. V square minus u square is equal to 2as, you will get the velocity. So, we have used the equation of kinematics and the equation of dynamics, Newton's second law of motion, and the law of friction also. This A is the retardation, not the acceleration. Negative acceleration is called as a retardation. If a solid cylinder, thin hollow cylinder and a sphere all with the same material or having the same outside diameter are allowed to roll down on an inclined plane, it is a pure rolling motion. Okay, pure rolling motion, no sliding, pure rolling motion. All surfaces are having the same coefficient of friction. What is the order of the bodies reaching bottom? Which will reach faster? Which will answer will be, all are having with the same material and having the same outside diameter. That means that rotational inertia is least for the sphere. So, answer is C. The reason is the rotational inertia is the least for the sphere. So it accelerates faster. It accelerates faster. So the sphere will reach the bottom faster as compared to the solid cylinder, which is as compared to the thin hollow cylinder. Fastest will be the sphere, quickly it comes, solid cylinder. What is the order of the bodies reaching the bottom? First sphere will reach, then solid cylinder, then thin hollow cylinder, because the rotational inertia is least for the sphere. A gear train comprises of 4 spur gears, radii are given. What is the ratio of the angular velocities to G1 to G4? Answer is C. Ratio is 2. 4 spur gears. The uniform link shown in the following figure has a mass of 12 kg. Okay. If the spring is unstretched at theta is equal to 0 degrees, determine the angle theta for the stable equilibrium. Neglect the surface friction, there is no friction here, and assume G is equal to 10 meters per second square. This length is 0.6 meters. The uniform link has a mass of 12 kg, that will be definitely acting at the center of gravity. This is the center of gravity. Determine the angle theta. We have to determine this angle theta for the stable equilibrium. So, if we just look at the no friction there, what are all the forces? If we just look at this, there is a normal reaction. Okay, no friction. There is a normal reaction here. There is a weight here. There is a spring force here. Yes, this is the spring force. No friction, no surface friction. Okay. And if we just look at this free body diagram, the net algebraic, we have to write the 3 equations of static equilibrium. Sigma Fx is equal to 0. If you see that, from this we can write that Rn will be 0. Okay. And sigma Fy should be equal to 0. So, there is a 2 forces S plus Rn. S plus Rn should be equal to the weight. The upward forces, this is upward force, there is upward force, there is a weight. Okay, no friction there because all are smooth surfaces, and sigma m is equal to 0. Okay, sigma ma, actually you can take this as a about this point A, we can take the 0. That means determine the angle theta for the so from this we can calculate S here. Okay, sigma m is equal to 0. From these equations you will get the answer theta as 60 degrees. Algebraic sum of all the moments. You may take about any point there. You may take about any point. If you can take the about point B. Suppose if you take the above point B, this moment of this Rn will become 0. This will have the anti-clockwise moment. This S will have the clockwise moment. If we just, this length is given as 0.6 meters. This is the length is given as 0.6 meters. Okay. About B you can take. Then so that this Rn moment will automatically become 0. So this is the 3 equations of equilibrium. Sigma Fx is equal to 0 means Rn should be 0. Sigma Fy is equal to 0 means weight plus weight is downwards, Rn is upwards, S is upwards. S is the spring force. 2 unknowns and 2 equations. We can easily solve the problem. A 0.2 mm thick strip is bent and laid over a frictionless pulley. There is a frictionless pulley. A belt is hold like this. This is the radius of the pulley. The maximum stress in the strip is, this is a strip, is bending, it is subjected to the bending stresses. We write the bending moment equation or bending stress equation. Sigma by Y is E by R. If this is the strip thickness is 0.2. This will be the Y. Y will be 0.2 by 2. R will be the radius of the pulley, that is 12.5, 25 by 2. 12.5. E is given, we can calculate the sigma. We can calculate the sigma. So many MPa. E is gigapascal, no? We can convert into the megapascal. Giga is 10 power 9 and we can calculate the maximum stress. This is the stress subjected by the extreme fibers. See, the sigma will be the maximum at the extreme fibers, right? Here or here. And Y is the half of that thickness of the strip, that is 0.2 by 2. And the radius of bending, radius of curvature of the bending will be the radius of the pulley itself. Everything I convert into the meters, you will get the answer. So this question was very typically asked, very typical and tough question also on the fluid mechanics. The velocity field of a certain two-dimensional flow is given by, actually it is given xi, not xy. Actually the correct formula I write here, velocity field is given by kx I bar minus y j bar. I bar and j bar are the unit vectors. K is equal to 2 per second. So from this, it is a velocity field of a two-dimensional flow. There. From this, I can say that, because we know that V is equal to U I bar plus V j bar. U and V are the two velocity components x along x and y directions. Therefore, U is equal to kx, that is 2x, because k is given as 2. V is equal to minus ky, that is minus 2y. You got the U and V are the two mutually perpendicular components. This is V. This is the velocity field V. Its x direction component is U. Y direction component is V. This is the velocity vector V. Right? If the fluid density is given, rho is given as 100 kg per meter cube and pressure at origin is 10 kilopascal. What is the pressure at point 3, 3? It's a very good question and slightly tough question also. It is one of the toughest question in the entire question paper. So we need to calculate the pressure at the point. To solve this problem, we have to make use of the Euler's equation of motion along x direction and y direction. What are the Euler's equations of motion along x and y direction? X minus 1 by rho into dou p by dou x is equal to ax. The convective acceleration for the steady flow, assuming the flow is steady, that is given as u into dou u by dou x plus v into dou u by dou y. Okay. X is the body force potential along the x direction. So that is taken as 0 because no body force potential acting along it. So I can write 0 minus 1 by 100 density dou p by dou x. What is u? 2x. Dou u by dou x is 2 plus minus of 2y into what is dou v, dou u by dou y? It is 0. It is a partial derivative. There is no y function. No? So it becomes 4x. So implies dou p will be minus 400x dou x. integrating, you will get minus 400 x square by 2, because we are integrating with partial derivative plus f of y, so plus some constant of integration. See, f of y, because we are integrating with respect to x, y should be treated as a constant, right? This is one way. This is for x direction. Similarly, for the y direction, if you write this, body force potential along the y direction is equal to acceleration along the y. This is a Euler's equation of motion along for the two-dimensional flow. That is u into dou v by dou x plus v into dou v by dou y. The body force potential along the, you can take x and y directions which are perpendicular to the gravity, we can consider. So this will be 0. You can take the x and y directions along the two directions perpendicular to the gravity direction, because body force will be existing along the gravitational field. But if you take this as x and this as y, there is no gravitational force potential acting along the x and y. I am assuming that x and y are acting along the two mutually perpendicular directions which are perpendicular to the gravity. If this is the z, this is x and this is the y, into dou p by dou y, u will be 2x, dou v by dou x is 0, because v there is no, this is a 0 there, plus minus 2y. What is dou v by dou y? Dou v by dou y will be minus 2. So it is plus 4y, this will become 0, plus 4y, it becomes, implies dou p is equal to minus 400 y dou y. If integrate that, p is equal to minus 400 y square by 2 plus f of x plus, because we are integrating with respect to y, we have to take the x as a constant. That is why f of x is coming. C is a constant of integration. So from this we can notice that by comparing these two, we can easily notice that this f of y will be minus 400 y square by 2, because the pressure at a point is the same in all the directions. So pressure has got a given function of x and y. So by comparing these two, I can say that P will be the minus 400 x square by 2 plus f of y. This f of y, therefore from this I can say that this f of y will be minus 400 y square by 2 by comparing these two. So we got the function pressure P. Therefore P will be minus 400 x square by 2 minus 400 y square by 2 plus constant. That becomes minus 200 into x square plus y square plus c. But he has given the boundary condition there in the question. Pressure at the origin, look at this, pressure at the origin means 0, 0. At x is equal to 0 and y is equal to 0, pressure is 10 kilopascal, but never keep it in kilopascal, it is 10,000 pascal. We have to maintain proper units also. That means, therefore C is equal to 10,000 pascals. Now we got the answer function for the pressure. Therefore, pressure P is equal to minus 200 x square minus 200 y square plus 10,000. Put x is equal to 3 and y is equal to 3. You will get P at 3, 3. That is minus 200 into 3 square minus 200 into 3 square plus 10,000 Pascal. Answer will be 6.4 kilopascal. Answer is B. Answer is B. 6.4 kilopascal. It's a excellent question. Actually, that kind of a questions are expected in a gate only. This kind, because that question carries 2 marks and takes time to do that. But for this exam, where the question for this ISRO exam, where the question can be directly read and put the solution, for most of the questions are like that. This question seems to be very unusual and not coherent with the other questions that are being asked in the exam. Definitely, this question carries a lot of weightage, lot of knowledge, lot of depth, and lot of time also consuming also. Actually, in the question also it is printed x suffix I. It should be x I bar minus y j bar. I bar and j bar are the unit vectors. Look at this question. A spherical water drop of diameter 2 mm splits into 8 small drops of equal size in air at a temperature of 25 degrees Celsius. Surface tension sigma was given 0.073 Newton per meter. Dynamic viscosity is given, that is a superfluous data. The approximate work done in splitting up the drop is work done in splitting the drop is equal to surface tension sigma into change in surface area. Change in surface area. First, what is the surface area, radius of each droplet? Let us keep. Total volume is same, 4/3 pi r cube. Initial is 2 mm, no? Pi r cube, a spherical drop, 2 mm should be equal to the 8 droplets, 4/3 pi r cube. I think r will be 1 mm. That is the radius of each droplet. Radius of each droplet. 8 droplets are there. One droplet is split into 8 droplets. Now I have calculated the radius of each droplet because the total volume remains the same. Before splitting and after splitting, the total volume of the liquid water remains the same. I have calculated the radius of each droplet after the droplet is split. Then sigma is there. What is that sigma? Therefore, work done is equal to sigma into change in surface area, 4 pi or initially total droplet, 4 pi r square before splitting initially minus 4 pi small r square into 8. Okay. Sigma is given there, then you can calculate, you will get the answer as 0.3 into 10 power minus 6 joules. So answer will be A, almost 0.3 get. The formula for calculating the work done in splitting a droplet into small droplets will be surface tension into change in the surface area, total surface area. Initial area is 4 pi r square, where r is equal to, what is r value? Here r is equal to 2 mm. What is small r? 1 mm. But convert everything into the meters. Answer is A. A face milling operation is carried out with a 100 mm diameter milling cutter having 4 teeth and sprint speed of 300 rpm. If the feed per tooth is 0.125 mm, what is the table feed in mm per minute? The answer is C. It is a problem on milling, which is the correct sequence of machining operations to be performed to finish a through hole of a large diameter. Drilling first, boring next, last is reaming. See, some questions are straight reading and putting, and some questions are requiring a lot of logic, lot of formula application, calculation, etc. So the question paper itself is carrying some very silly, simple, direct reading questions, and some questions are tougher and requiring mind-boggling and calculations, etc. In an abrasive jet machining, the main mechanism of material removal takes place due to mechanical impact. Just read that question and put the answer. Answer is C. Either too simple or rather too tough. The question paper was like that, which is identified as the coefficient of momentum transport. This is the one which is very, very important, particularly in the hydrodynamic boundary layer. The thickness of the hydrodynamic boundary layer is particularly laminar. It has got a lot of things, square root of the kinematic viscosity. Kinematic viscosity is the one which will be, this is talking about rate of momentum diffusion. Rate of momentum diffusion or momentum diffusivity. This kinematic viscosity is also called as momentum diffusivity. It is there in the Prandtl number also. So answer is B. What is the most economical depth of the flow in an open and rectangular channel? See, open channel flow, it is not there in mechanical, but I don't know why this question was asked in the ISRO. But this is a very unusual, unexpected question in the fluid mechanics. It is the open channel flow, OCF, they call it as the. So the depth of the flow is half of the width of the channel. That is the most economical depth. But actually this is generally we don't study, maybe mechanicals don't study this open channel flows anywhere in the fluid mechanics. For water, latent heat of freezing is given. Specific heat capacity is 4.19. Quantity of heat to be removed from 1 kg of water at 30 degrees. The water is there at 30 degrees Celsius, 1 kg. To freeze it, to turn it into ice, first of all you have to bring in that 30 degrees water to the 30 degrees Celsius water, 0 degrees Celsius, because at 0 degrees Celsius this heat is called as the sensible heat, and we have to remove the further heat to get that ice. This is a water at 0, this is ice at 0 degrees. This heat removed is called as latent heat. So total heat is sensible heat plus latent heat. First of all, you have to bring that 30 degrees Celsius water to the 0 degrees Celsius water, and at 0 degrees Celsius you have to remove that latent heat, which is given as 335, to make the water into the ice. That is Cp into delta T plus latent heat. What is the Cp given? 4.19. What is the temperature change? 30 minus 0 plus 334. Answer will be 459 kilojoules. Answer is D. A point load applied at shear center of the beam induces, there can't be any twisting. So answer will be no twisting possible. No twisting. Therefore, it can be only pure bending. A point load applied at the shear center of the beam can induce only the pure bending and no twisting. This is the question given on the welded design of the welded joints there. A 50 mm diameter solid shaft is welded to a flat plate all around by a fillet weld of 4 mm leg size as shown in the figure. If the allowable shear strength of the weld material is 100 MPa, the maximum approximate torque in Newton meters that the welded joint can sustain under pure torsion is. Therefore, radius is 25 mm. This T will be A by root 2. T by J or IP also we can call is tau by R. This J will be, therefore the torque will be, shear strength was given 2 pi T into R square. Shear strength was given, this tau is the shear strength you can take, you will get the answer 500 pi by root 2 by substituting the given values there. T is A by root 2. This is the cross-sectional view of the welded portion. A cam and oscillating follower mechanism is shown in the figure below. The mobility of the mechanism, N is 4, L is 3, H is 1, R is 1. Link 3 has redundant degrees of freedom. Therefore, degrees of freedom is equal to 3 into N minus 1 minus 2L minus H minus R. That therefore degrees of freedom will be 1. Answer is 1. Links are noted here. This is 1, 2, this is 2, this is 3 and this is 4. The next question 42 is asked like this. A body is subjected to a biaxial state of stress as shown in the figure below. It is a biaxial state of stress. The magnitude of the normal stresses. This is 60. Okay, P1 is plus 60 MPa. It is a tensile. This P2 is 40 MPa. Okay, there is a shear stress of 30 MPa. Okay, now he is asking to calculate what is the normal and shear stresses acting on the 45 degrees plane. Okay, what is the normal stresses and what is the shear stress? Okay, normal stress, we have the formula, that is if this is P1 plus P2 by 2 plus P1 minus, but this is of negative. Mind that it is of negative side. Why? Because it is of compressive. So it is minus 40. It is plus 60. P1 minus P2 by 2 cos 2 theta plus tau sin 2 theta. This is the normal stress acting on that plane, which is considered at 45 degrees. What is the shear stress? What is the shear stress? P1 minus P2 by 2 sin 2 theta plus tau cos 2 theta. Put theta is equal to 45 degrees. Here the theta is 45 degrees. Okay. Now just substitute that. Here the P2 should be considered as, here the P2 is minus 40, P1 is plus 60, tau is 30. We can directly see that normal stress, answer will be the C there. Normal stress, if we just look at that, sin cos 90 is 0, sin 0, no, this will vanish there. It will become, look at this, P1 40, P1 is 60, 60 minus 40 divided by 2, this is 20, and that tau is sin 90 is 1, tau is 30, 30 plus see, P1 60 minus of 40, that is 20 divided by 2, this is 10, this will be 30, 30 plus 10, 40, answer is C. You can directly see one answer there. You can see this answer there. If you substitute all these values here, you get, this is the normal stress, this is the shear stress. Answer is C. What is the revolving joint of the robot? That is the V joint. Revolving joint of the robot is called V joint. The diagram below is showing the various criteria of fatigue failure. Which option is the correct representation of these criteria? E, Y and U represent the endurance, yield and ultimate strength respectively. Answer will be the A. 1 is Soderberg line, 2 is Goodman line, 3 is Gerber line. Answer is A. 44. Which of the following represents the Stirling cycle? Stirling cycle has 2 isothermals and 2 isochorics, 2 constant volumes, and so answer is first one and last one, 1 and 4. Answer is C. These two are isothermals, constant temperatures. Stirling cycle is a reversible cycle we can consider. Its efficiency may be equal to that of the Carnot once you provide the regeneration. Ericsson cycle has got 2 isobarics and 2 isothermals, whereas this has got 2 isochorics. 2 isochoric means what? Constant volumes and 2 constant temperatures. Isothermal means 2 constant temperatures and 2 constant volumes, that is the Stirling cycle. Rapid and sharp changes in fluid properties mean a very small region of a gas flow. When a gas flow is happening, during a very small space, there is a rapid erratic changes in the properties like density, pressure, etc. Such thing is called as the shock wave, which would happen in the diverging portion. It is like this. Pressure keeps decreasing and abruptly pressure will rise. So that would happen only when the supersonic flow will get converted into the subsonic flow. So a shock wave could happen only in the this is the throat section. Only in the diverging portion it may happen. This is the pressure. This is the pressure variation. Pressure keeps decreasing and velocity keeps increasing, but the flow will be abruptly becoming supersonic flow to the subsonic, where the pressure abruptly increases and velocity decreases. That is called as the shock wave. An abrupt or sudden deceleration of gas or steam also, of gas from supersonic flow to subsonic flow, from supersonic flow to subsonic flow, during which properties rapidly changes, during which pressure, density, velocity, etc. all rapidly change, very quickly change, or rapidly change is called pressure, density, velocity, etc. You can see here, pressure is abruptly increasing, velocity is abruptly decreasing. This is called as the shock wave. It will happen only in the diverging portion of the convergent divergent nozzle. It will never happen in the converging portion. Don't get confused about the cavitation, but cavitation would happen only when the liquid is bubbling into the vapor. Cavitation is phenomenon when the liquid is bubbling into the vapor bubbles, when the local pressure falls less than its vapor pressure value. Cavitation is connected to a liquid bubbling into the vapor and the vapor collapsing and abruptly changing the. But this he has clearly given. People may get confused with the cavitation, but cavitation would happen during a liquid flow, water flow. Okay, we are clearly given a gas flow. It means it is a shock wave. Sublimation means a change of phase from the solid to the vapor is called as the sublimation. This 20 mm diameter aluminum rod is turned to 19 mm in a single pass. He is asked the material removal rate. Answer is A. If the axial speed of the tool is given, the spindle rotates at 600 rpm. The material removal rate is, answer is A. It is a machining problem. A planar 4-bar mechanism was given, revolute joints as link lengths were given. The link to be fixed to obtain a double crank mechanism is AB. Because based on the dimensions, we have to decide that which link has to be fixed to obtain the double crank mechanism is AB. So this is a problem on heat transfer. It is a problem on heat transfer. The wall of a chemical plant is modified. A, we can take it as 1, some thermal conductivity, and thickness B. There is some heat transfer happening. And this is modified to by adding 2 additional layers. 2 additional layers are added, and thermal inner layer of the half of the thickness, if this is B, 2 additional layers were added. Half of the thickness, original wall material, inner layer half of the thickness, outer of the same thickness of the original wall. This is again B. Inner layer is of the half of the thickness and outer layer of the same thickness as the original wall. 2 additional layers having half of the thermal conductivity. If this is K, this is K by 2, this is also K by 2, this is the thickness B. Now what is the rate of flow here? If this is Q1, what is this Q2? Now what is the thermal resistance here? B by K. What is the thermal resistance here? B by K plus B by 2 divided by K by 2 plus B by K by 2. It will become what? 2B plus 2B, right? No? This 2B plus B plus B, it becomes 4 into B by K. That means, therefore, thermal resistance is increased by 4 times. Is increased by 4 times. Therefore, Q reduces by 4 times. Wow. Answer is D, 25% of the original. We have added 2 additional layers having the thermal conductivity. Look at this, is modified, is having the half of the thermal conductivity of the original. Inner layer is half thickness and outer layer is of the same thickness. So thermal resistance has increased by 4 times. Therefore, Q will reduce by 4 times. Q2 will be 1/4 of Q1. You can think of that. Q2 will be 1/4 of Q1. 3 metal balls are suspended by 3 wires. The masses of the balls were given. This 2 kg, 4 kg, 3 kg. Wire diameters are respectively 2 mm, 1 mm, 1 mm. What is the correct order of increasing stresses? We have to calculate the stresses there. So, see, for stress of sigma of the C, if we just look at that, 3 kg by, okay, pi by 4 d square, 1 square, right? Sigma of the B, if you see, sigma of the sigma of the wire B. For the C, this is the only one load acting, right? For this, if you just see wire B, this is wire C. This is wire C. Wire B, there are two loads are there. There is a 4, if you just take the sections here, 4 plus 3 divided by pi by 4, what is the B? 1.2 whole square. This is the stress in wire B. Stress in wire A, if you just take section here, what is the total load acting? 4 plus 2 plus 3, 6 plus 3, 9, 4 plus 3 plus 2 divided by pi by 4, what is the first one? 2 square. Now we can easily calculate which stress is more, which stress is lesser. If you just take the C, wire C, only the load acting is, this one is acting 3 kg. Okay. So answer will be sigma A is lesser than sigma C is lesser than. So answer is sigma A is lesser than sigma C is lesser than sigma B. The only concept here is, if you take the section here, only this load will come. If you take the, for the wire B, only these two loads will come. If you take the wire A, all the 3 loads will be coming, acting downwards. Okay. This is a simple engineering mechanics question. A small ring Z carries a vertical load. Here there is a vertical load and 2 strings are there. There is one string here, there is one string here. Okay. So if you just draw the free body diagram for that ring Z, there is, this is weight of A. What is the weight of A? 27.3. Okay, kg. This is RB, you can say force in B. This is the force in ZX. This is the force in ZY. That is nothing, because this is a frictionless pulley. This is a frictionless pulley, you know, that is weight of the B we can take. So you can write this this Lami's theorem. Lami's theorem you can write 60 plus 45. This is 105. This angle. Okay. You have to just calculate the angles there. This is alpha, if this is beta. Okay. WA by sine 1, Lami's theorem we can write, is equal to FZY divided by sine alpha is equal to FZX by sine beta. We can calculate all the 3 forces. There are 3 forces here, weight, there is one force here, there is another force here. This theorem is also called as the Lami's theorem. When there are only 3 forces are acting on a body and keep that body in equilibrium, when there are 3 concurrent forces are acting on a body and keep that body in equilibrium, each force will be proportional to the sine of the angle between the other 2. That is famously known as the Lami's theorem, or sine rule you can apply and you will get the answer. For all the 3 forces you get. This is given, this is weight of the B is acting here because it is a frictionless pulley. It is a frictionless pulley, right? What is the power of, actually the question itself is wrongly set. What is the power of 2 ton air refrigeration is given. 1 ton is approximately 3.5 kilowatts of refrigeration effect. Okay. and latent heat of ice is taken and specific heat capacity. Okay, therefore 2 ton will be 2 into 3.5, approximately 7.5 kilowatts. So, but he has given 2 ton is given slightly more, 1 ton is 1000 kg, 1016 is ton they call, take it as, the answer will be 7.7 kilowatts. 1 ton of refrigeration effect means 3.5 kilowatts, but power is using the word power. When you to calculate the power of a refrigeration system, you require the COP. So, COP did not give, but he is otherwise asking about the refrigeration effect by talking about the ton of refrigeration. 1 ton of refrigeration is 3.5 kilowatts. The air standard Otto cycle, air standard Otto, the thermal efficiency is 1 minus 1 by R to the power of gamma minus 1. 1 minus 1 by R is given as 9, 1.5 minus 1, it is 66.67 percentage. R is the compression ratio. Gamma is given as 1.5. For calculation purpose he has given, usually the gamma of the air will be 1.4. Only for calculation purpose he has given it as the 1.5. Flat belt run over a pulley, transmitting power was given. The power transmission formula is T1 minus T2 into the tension, no? Angle of flap will be given there. This is the angle of flap, and ratio of the tensions, e to the power of mu t theta, and in initial tension is the average between the two, that is the initial tension. So, if the initial tension is increased by 10%, what is the effect on the power transmission? By using these three equations, you will get the answer. This is the angle of flap, which is given as 165. Here, this could be calculated from EI into, from the slopes and deflections equation. This is the bending moment. From this answer we will be obtaining as C. Equation of the elastic curve for the cantilever beam of uniform cross section. The preferred choice of the steel material for the cryogenic cover is austenite. Preferred choice, but the very low temperature. Cryogenic applications means 0 Kelvin to 113 Kelvin. Very low temperature applications. That is called as the cryogenic domain, where this is the steel material that is preferred choice, particularly for the storage of the liquefied oxygen, etc. These temperatures we will be storing the liquid oxygen also. An aluminium ring of mean diameter at 5 meter, aluminium ring was given, say D1 diameter, dip into liquid iodide bath. What is the ambient temperature? Ambient temperature is 24 degrees Celsius. It is dipped into the liquefied nitrogen. What the temperature is 77 Kelvin. This temperature will be 24 plus 273 Kelvin. Okay, this is T1, this is T2. The coefficient of linear expansion alpha is D1 minus D2 divided by T1 minus T2 D1 minus D2 divided by T1 minus T2 divided by d1. That is been given as 20 into 10 power minus 6. He is just asking what is the d2. Everything is known there. d1 has been given. d1 is given as 5 meters. This is the coefficient of linear expansion. Okay. This is the coefficient of linear expansion of the aluminum alloy. T1 minus T2 is the change in temperature. D1 is the initial diameter. Once it is dipped into the low temperature liquid, the diameter will contract. Okay, diameter of the ring will reduce. Answer will be 4.978. A. A is the answer. A traveling crane was given. This question 58 question is answer A. A satellite of mass 100 kg is attached centrally to a rocket stage of mass 900 kg using a separation system. If in the space the satellite is to be separated and ejected using 10 numbers of identical spring thrusters having the stroke of 30 mm. Assume springs are fully transferring energy and angular body rate of the bodies are negligible after separation. What is the stiffness of the spring required to get the satellite axial relative velocity of 1 meter per second? See, the work done by each spring, it will be half kx square, where k is the spring stiffness, x is the displacement. X is the displacement of spring from its free length. Okay. So, all the total work done by all the springs, total work done by all springs should be equal to the kinetic energy imparted to mass, because that is ejected. Springs are ejecting the satellite of mass 100 kg, mass 100 kg mass, imparted to 100 kg mass of 100 kg. Okay. So, based on that work energy theorem, we can calculate what is the spring stiffness. That is the principle behind the question. This is the journal bearing question. A journal bearing of radius R1 and radial clearance C1 has a Sommerfeld number S1. Another journal bearing of radius R2 and radial clearance C2 has a Sommerfeld number S2. All other parameters remain the same. If R2 is equal to R1 and C2 is equal to C1 by 2, then S2 by S1 is. The Sommerfeld number formula is this: Zn by P, the bearing characteristic number, CD is the diameter clearance. Therefore, S1 is equal to Zn by P. This is the radial clearance, we can say. S2 is Zn by P. Therefore, S2 is equal to 16 S1. So, answer is C. This is a Sommerfeld number. This is the diameter clearance. This is the radial clearance. 61 is regarding the theories of failure: Rankine theory, Tresca theory, Saint-Venant theory and von Mises theory. Answer will be C. Matching problem. Which of the following is not a casting defect? It is a spatter. A is the answer. See, some questions are directly being kept by just by reading it. Which of the following improve weldability of the steel? Low carbon content and good affinity to oxygen. That will low carbon content and the weldability. Weldability or the steel will be more if the carbon content is low and the good affinity to the oxygen. Answer is C. The moment of the resultant of a concurrent forces with respect to a center in their plane is equal to the algebraic sum of the moments of the components with respect to the same center. This theorem is famously known as Varignon's theorem. The moment of a force, the Varignon's theorem states that the moment of a force is equal to the moment of a force about a point is equal to the algebraic sum of the moments of its components about the same point. I repeat the statement. This is a very famous theorem in engineering mechanics, particularly statics. The Varignon's theorem states that the moment of a force about a given point is equal to the net algebraic sum of all the moments of the components of the force about the same point. That is known as Varignon's theorem. A. Stress strain curve of three types, very clearly seen. This is the G is the plastic. G is plastic. Okay. F is ductile. E is brittle. E is brittle. F is ductile. G is plastic. Answer is A. This curve, stress strain curve, this is the ductile, this is the brittle, this is the plastic. What is the true in respect of the self-locking screw jack? Its efficiency should be less than 50 or maximum 50%. Friction angle is more than the helix angle. Both 1 and 2 are correct. Then only it can be self-locking screw jack with square threaded. Efficiency of the screw jack must be less than the 50% and the friction angle should be more than the helix angle of the thread. The commonly used flux for the brazing is borax. A machine member is subjected to the fluctuating stress, endurance limit was given, factor of safety is used in the design is 3.5, then the maximum allowable stress down sigma naught in MPa according to the Soderberg fatigue criteria is 100. A plane stress element in a structural member under loading has sigma x, sigma y and tau xy, where P is greater than 0. Yield strength of the material is 300 MPa. If the member is designed using a maximum shear stress theory, then the value of P at which the yielding starts is. This is also called as the Guests or Guests and Trescos theory. Maximum shear stress theory is also known as Trescos theory. It is the maximum shear stress. Tau is given by half into sigma y minus sigma x whole square plus 4 into this maximum shear stress will be exactly half of the yield strength of the material. Will be half into, by substituting all these things, you will get 4p square plus 4 into 3p square. It will be half into 4p, that is 2p. P will be 300 by 2 into 2, it will be 75 MPa. Trescos theory or Guests and Trescos theory, which is also called as maximum shear stress theory. For a particular project, 6 activities are to be carried out. The precedence, relation and duration of activities are as per the following table. The minimum project completion time in days is. For path 1, 2, 3, 5, 6, time is 29 days. For path 1, 2, 4, 5, 6, time is 6 plus 8 plus 6 plus 7, 27 days. Therefore, project completion time is 29 days. Answer is C. Radius of the Mohr circle is maximum shear stress. It's one of the very important question in the principal planes and principal stresses. Radius of the Mohr circle is maximum shear stress. In a casting process, a horizontal channel through which the molten metal flows from pouring basin to reach mold cavity is called as a runner. See, some questions are very, very direct and very simple. 3D printing techniques, all the above. The property of the material that represents the maximum amount of the strain energy that it can absorb before it fractures under load is called as modulus of toughness. The total area of the stress strain diagram. This area, this area is called as the modulus of toughness. Whereas the if you just take the modulus of toughness, actually, if you just take if you take up to the elastic limit, if you take that area is called as the proof resilience or modulus of resilience. If you take the area of the stress strain diagram up to the elastic limit, that is called as the proof resilience or modulus of resilience. If you take up to the breaking point, it is called as the modulus of toughness. Answer is B. A Carnot refrigerator works between temperature ranges was given. Which of the refrigerant has got better COP? All give the same COP. COP of Carnot refrigerator is independent of working fluid. It depends only on the temperatures, is independent of working fluid. It depends only on the temperatures. It depends only on temperatures, nothing else. As long as the temperatures remain same, COP also will remain the same. A round wire helical spring is loaded by an axial force. Helical spring, axial force, maybe tensile force or compressive force. The maximum shear stress in the wire cross section will be at the inner fiber. The power transmitted through a spur gear with 20 degrees pressure angle mounted at the midspan of the shaft, supported on bearings at the ends. The nature of the stress induced in the shaft is B. Normal stress due to bending and shear stress due to torsion. Both. Normal stress due to bending because of the weight of the gear and due to the shear stress due to twisting moment or the torsion. This is a very good question. A cylindrical body of diameter 2 meter, of height 1.5 meter. Its mass was given 2000 kg seawater with its axis vertical. This is axis. Some lighting mass is kept there. Some mass is kept. This mass is kept. Water level is at least 0.5 meters below the top surface. This is water level. This is water level. That is 0.5 meters. That means remaining body is immersed here. 1 meter is inside that, inside the water. This is 1 plus 0.5, 1.5. What is the maximum mass M that can be placed? Very simple thing. Total weight should be equal to the force of buoyancy. What is the total weight? 1000 kg into 2 plus mass into 9.81, right? Into 9.81 should be equal to the force of the buoyancy, that is weight of seawater displaced. What is the seawater displaced? What is the volume of the body is inside here, no? That is pi by 4 d square, that is 2 square into only 1 meter is inside. That is a volume. What is the specific weight of the sea water? 9.81 into 1.02 into 10 cube, because left hand side is in newtons. This is in newtons, right? This is in newton. So this is also converted into the newtons there. Then you will get the mass. Mass, you will get the answer as 1202. C is the answer. Very simple question. You already, the weight is 2000 kg is acting. Apart from this, how much extra mass will be there? You have to keep. So the total weight will be 2000 plus mass, that is a mass into g, that is a weight, so many newton, should be equal to the weight of the seawater displaced, that is the force of buoyancy. According to the Archimedes principle, the force of buoyancy is the weight of the liquid displaced by the body. This much body is inside, that much water is displaced, right? Only 1 meter of the log is inside the water. So answer is C. I just applied the Archimedes principle, that is the total weight. Total weight, that is a principle of flotation. What is the principle of flotation says? The weight of the body must be equal to the force of buoyancy. Force of buoyancy is calculated from Archimedes principle, that is the weight of the seawater displaced. What is the seawater displaced? Volume of the seawater displaced into specific weight of the seawater. He has given the specific gravity. Okay, specific gravity means specific weight of the seawater divided by specific weight of the water. Okay, but here I multiplied with 10 cube, so that final answer I want to get it in Newton. This question doesn't have the, you may even challenge that in the exam. This doesn't have the answer. Euler's equation is applicable to inviscid liquid, correct. Bernoulli's equation is applicable to steady state, correct. Viscous forces are not considered in the Navier-Stokes. This is wrong. It is considered. The main difference between the Euler's equation of motion and the Navier-Stokes equation of motion is, in the Euler's equation of motion, viscosity of the fluid is 0. Whereas when you talk about the Navier-Stokes equation of motion, which is also a conservation of linear momentum, like Euler's equation of motion, we consider, in the Navier-Stokes equation, we consider the gravity, we consider the pressure, we consider the viscous. All three will be considered. Whereas in Euler's equation of motion, we consider the pressure and the gravity only, no viscous. So this is wrong. Viscous forces are not considered, is wrong statement. Surface tension are considered in the Navier-Stokes. No, they don't consider. Only in the Reynolds equation, etc. Though they are, in fact, surface tension and they are insignificant forces, and compressibility forces are there only when the velocity of the fluid is very, very, very high and density changes are significant. So this is also a wrong statement. They said are considered. Only 3 forces are considered in the Navier-Stokes. Actually, are not correct is giving. 1 is not. 3 and 4 are correct, are wrong. 1 to 3 are correct. Actually, no answer here. No correct answer given. I can say no correct answer. So this question is contentious. In the entire question paper, this question is contentious. Euler's equation is applicable to inviscid, that is correct. Bernoulli is applicable to steady state, that is also correct. 3 and 4 are wrong. So no answer is exactly matching that. This question is a very good question. Having a mass of, here one hoist is there. This is one hoist that is just dropped here. You pull back and by the cable, and cable is cut off. The plane is right. Now this cable is cut off. Immediately this will fall down, right? With what height, with what velocity it will hit it here? That answer is very simple. Change in potential energy of mass is equal to change in kinetic energy. Law of conservation of energy we can write. Okay. So what is the change in potential energy? This angle is given. First initial this angle is given. This is 60. This angle is given. This is 30. So initially if we just take this one as x, cos 60 x by 20, this is given as 20, right? And at this moment this is y. Cos 30 is y by 20. Okay. mg into, from here, no, y minus x is equal to half m v square. You will get the velocity as 12.1 meters per second. When you just this link is cut off, this will fall down, right? The change in elevation is the change in potential energy will give rise to the change in velocity. Will the change in kinetic energy. Change in potential energy is the change in kinetic energy. Initial potential energy it has, but when it hits here, potential energy becomes 0. Initially velocity is 0. Okay. But when it is hitting here, it is moving with a velocity v. So it is hitting here, that the difference in heights are just calculated. In the question number 81, D is the answer. I am giving the aptitude answer. There are 15 questions aptitude. 82 is A. 83 is A. 84 is D. 85 is C. 86 is D. 87 is A. 88 is C. 89 is A. 90 is A. 91 is A. 92 is A. 93 is A. 94 is C. 95 is also C. So with this I had given all the solutions. But if you just look at me, if you just ask me, I must have seen so many types of competitive examinations papers for the last 25 or 30 years of my experience, because I have a huge experience of gate coaching and competitive examination coaching across all India. I have taught for about 15 years at Delhi and more than 10 years at Hyderabad and elsewhere in Delhi, Chennai and Bangalore, etc. And so many coaching institutes have been associated. My name is Sekhar. I am one of the most experienced faculty in GATE and also the engineering services, and having seen so many papers for so many years, for so many types of all India examinations, this question paper is very typical in the sense, some questions just read it and keep it. Some questions we require you have to apply the mind, we have to keep the you have to spend a good amount of time, like that, calculation, etc. So the two extremes of the types of questions are there, but some data, as I have shown you, a question on Euler's equation and Bernoulli, there is some ambiguity is there, answer is not there, except one or two ambiguities in the entire paper. I can rate the entire paper as moderately, I can say moderately tougher, moderately, not easy, not very tough. You can say, you can consider it as a moderately tougher, because it's something we need to remember the data and answer the questions. Like this, I have to ask some production questions there. I have asked some particularly welding questions, etc. Some things you need to remember, some things you need to use the logic. But overall, the paper is good. Definitely better paper than the previous ISRO year's questions. So with this, I have finished the solutions. All the best. Good luck.